Hi everyone. So today we'll cover a core concept that we learn in SRM. It's about the least squares estimator. This is from chapter 1, which is the simple linear model. Let's look at what it is. So in that chapter, we write our model in this form. So the equation is yi equals to beta naught plus beta 1 times xi plus the error term ei. That is the model. After that, we fit a model. The fitted model looks something like this. Y hat equals to beta naught hat plus beta 1 hat times xi. What are these hats telling you? These hats basically tell you these are all predicted values. So yi hat basically means the prediction that we have from the model for our actual yi. That means finally we define the term called residual. What is that? Residual is the actual value of yi which we have from our sample and the predicted value of yi which we have from our model. What is this method that we are talking about? This least squares estimator. This is what we calculate when we begin studying linear regression. So, least squares estimator, the process is as follows. We minimize the residual sum of squares. We minimize this residual sum of squares. What is that? Residual sum of squares is basically this is the residual which I have just written above. When you take a square of that and you sum across the entire sample, what is the sample? See, I've written here that I goes from 1 till n, which means you have n items in your sample. And when you take the square of each of these residuals, so this is the square of each of these residual term, and then you sum across for all your n values, that gives you the residual sum of squares. Now you need to minimize that with respect to beta naught hat and beta 1 hat. This RSS, which is the residual sum of squares, this RSS is actually a function of beta 1 hat and beta naught hat. Why? Because yi hat, if you see here, yi hat has this expression beta naught hat plus beta 1 hat times xi, right? So this entire thing becomes a function of beta naught hat and beta 1 hat. So finally, we just need to minimize this expression. What does minimization mean? Via calculus, we know that when we want to minimize a function, we need to differentiate that with respect to once with beta naught hat and then again with beta 1 hat. And we equate that to 0. We differentiate this equation once with beta 1 hat, then again with beta naught hat, and then we set that equal to 0. When we do this, we get two equations, which is in linear regression, we call them normal equations. This is a very important concept about normal equation. And once you have these normal equations, I'm not writing it in detail, but yeah, the idea is this only. You'll get two equations called normal equations, and finally, when you solve these two normal equations, you will get your expression for beta 1 hat, which is as follows. So it's just the sum of xi minus x bar times yi minus y bar upon the sum of xi minus x bar ka square. This is also called the slope coefficient, and beta naught hat is called the intercept coefficient. What is that? That is simply y bar, which you know from the sample, beta 1 hat, which you have just estimated above, and the x bar, which is again known from the sample. So this is what we do when we say least squares estimator. We minimize the RSS with respect to beta naught hat and beta 1 hat to solve for these two estimators. And when we have a given sample, then using the value of what is a sample? In this case, sample would be some values of xi and yi for all these I going from 1 till n. So when you have a sample of size n, you can use actual values and calculate your beta 1 hat and beta naught hat. Those would be the estimates, the least squares estimates. Thank you.